Hello everyone and welcome to my channel. My name is Dr. Korachi and in this video we're gonna talk about embedded operating systems, the hidden threat. Now, by the end of this module, you should be able to explain what embedded operating systems are and where they are used. Describe IoT and other embedded operating system. Identify vulnerabilities of embedded operating system and the best practices for protecting them. Now, first of all, let's try to understand what is embedded system. An embedded system basically, it's a very small computer system that it is not a general purpose PC or server. You can find it in different sizes, and it's designed basically to perform a specific task within a larger, mechanical or electronic system. It's typically combination of hardware and software designed for an application. You could find it in a different places here. You could find it like in automobiles, like engine control system, household appliances, your microwave, washing machine, medical devices, heart monitors, industrial control system, consumer electronics, and even toys. So embedded operating system, OS. This one is basically a small program developed specifically for use with embedded system. It's stripped down version of operating system. Okay, comparing to the operating system used on a general purpose computers. It's designed to be small and efficient, which makes it limited in memory and processing power and also in storage space. This could be good for very specific application and very limited hardware also. Does not make it bad. Now, the key features of it is efficiency, because it is limited in certain things, it's designed to be efficient in the use of resources like, the memory, processing, and power, and in storage. It designed to be reliable and to operate without interruption. And also it can be used in real-time capabilities, meaning it can respond to events within a specific time period, you know. Now, there's like Linux, for example, a free RTOS. It's a real-time operating system that is used in embedded systems that require deterministic performance. Another example, the VAX works or VX works. It's a real-time operating system that they use in embedded systems that require high performance and reliability. And the other one here, the QNX, okay, use an embedded system that require graphical user interface. Now, the real-time operating system, RTOS, is typically used in devices such as programmable thermostat, appliances controls, and spacecraft. Okay, now keep in mind that RTOS is an operating system designed to handle real-time application in which the output must be produced within a specific time constraint, often referred to as deadline. Now, one of the key features here, it has a preemptive multitasking. What does it mean? It means that RTOS can interrupt a specific task that is currently running and switch to another one that has higher priority. Now, this ensures that all tasks to be completed within the time constraint or deadlines, even if the system is overloaded. Deterministic scheduling means that the RTOS can guarantee that a task will be executed within a certain amount of time. This is important for real-time application where the output must be produced within specific time. Okay, low latency, means it responds to event quickly, fast, which is also, this is important for real-time application, where the system must respond to events in real time. Obviously, you could see that it's a small size and memory footprint, which makes it efficient. And, basically it can be used in a constrained resources embedded systems here. Here also, You could see it in a corporate buildings, for example, like many embedded system, like firewall switches, routers, web filtering, NAS also. Embedded system are all in the networks. Performance essential function for route network traffic and block suspicious activities as well. So you can see it everywhere you interact with. Now, let's look at something really, really serious called firmware modification. Recently, security researchers did a reverse engineered the system on a very popular hardware firewall chipset, which is the firmware. They basically inserted modified software to control the firewall's behavior. And now imagine for yourself what the hacker can do if they're able to get to the firmware and modify it. This means they could basically modify the firewall to copy network traffic passing through the interface. Stuff like if you want to learn more about, countermeasures or preventing firmware attacks, you could read this link, for example. Now let's look at the recycle and comment code. That's another issues that we need to look into it carefully. Basically, this is a common software engineering practices here, doing recycle or common codes because they could save time and money. By reusing code that are already been written and tested, developers can avoid having to write it from scratch. However, the problem is here. Reusing code can also introduce common points of failure or vulnerabilities. This is because if there is, like I said, if there's a vulnerability in the shared code, you know, that those guys, they used it, it will be exploited by the attackers. This is why it is very important that you do code review for any type of common codes before you add it to the application. Of course, there's a Windows Linux vulnerabilities and Windows CE. This is a trimmed down version of Windows Desktop. Uh, you rarely see it in 2022 and now, but still worth knowing about it. It's no longer in active development or support since 2018, by the way. Now, instead, they got replaced with Windows 10 IoT, and now we have Windows 11 IoT Enterprise, which was released in 2022. It has full feature edition of Windows 10 IoT. It has pretty much similar interface to Windows 11 Pro, except the interface is designed to accommodate the needs of embedded devices. In other words, it has a specially designed interface only suitable for embedded devices. There are two editions of the Enterprise, LTSC and the Enterprise SAC. I strongly recommend to go over it. And the good thing about it that it provides full Windows API and it's designed for industrial automation, medical devices, retail, transportation, and even smart building. Now, it is designed to make things easy for developers. How? Well, it supports a variety of programming languages, like C, C Sharp, C++, JavaScript, Python, which makes it easy for developers to choose the language they want, and they are comfortable with. It provides a rich set of APIs. You know, Developers can use it to interact with the operating system and hardware. Again, this makes it easier for developers to build their own application and that are tailored to a specific needs of their devices. Now, developers and users can enjoy a large community of different developers in order for them to get help and support when needed. And it is easy to deploy and manage, okay, again, because it is small and designed to make it easier for developers to get their application up and running quickly. Now, there's other proprietary embedded OS like VxWorks. Now, this one use embedded real-time operating system developed by Wind River System. It used in many different environments, application like the aerospace and defense, you see it here. Designed for demanding application. It is known for its reliability, determinism, and scalability. which is that's why it makes it very attractive to many companies to use it in their system. Now, according to Wind River, it is built on an upgradable, future-proof architecture to help you rapidly respond to changing market requirements and technology advancement. Now, another one is the Green Hill software. Produce different types of embedded operating system. One of them is part uh, added to the F-32 Joint Strike Fighter, and it has a feature called multiple independent levels of security safety, MILS. Embedded OS certified to run on multiple levels of classification. What does it mean? Now, we know the F-32 is a military aircraft that designed to be highly secure and reliable. Now, in order for to meet these requirements, the operating system used here, okay, must be able to run multiple independent levels of security and safety here. This means that the operating system must be able to isolate different applications and data from each other. This is very important. Why? Simply, a failure in one application does not affect the others here. Now, also here, if you look at the classification, now it is certified to run a multiple level classification. Now, this means that the operating system here has been tested and approved to be used with sensitive data such as the classified military information. Now, you can always find it in printers, routers, switches, etc. And this software can, they have their own commercial RTOS and using Cisco's ultra high availability routers and Logitech Universal remotes. Now, here we have another one called Real-Time Executive for Multiprocessor System, RTEMS. This is an open source embedded OS. It also used in space systems. It supports processor design, designed specifically to operate in space. And basically think about it this way. The RTMS is a deterministic operating system, which means that the order taken to run task you know is predictable. This is important for applications that require repeatable result, like telecom system, medical devices, and so on. And the other important feature is a scalable OS, which means that it can be used in wide range of hardware platform, even from small embedded devices to large servers. Now, it's important for you to understand the difference between monolithic kernel OS versus microkernel OS. By looking at this graph here, you could see the difference in the architectural design of each one of them. Now here, in the mono one here, you could see this is large program that contains all of the operating system's code. Now, the micro one, on the other hand, is a small kernel that only provides the essential services that are needed to run the operating system. And that's the stuff that we covered previously in the slides. All other services are implemented as a separate modules that run in user space. Now, if you look at this table here, there's the feature, the mono, the micro, the structure, single large program. This one is small kernel with the separate modules. Services provide, in terms of services, the mono provides all services. The micro provides only essential services. Now, this means in terms of security, the mono less secure, because here obviously you can see there's more line of codes are added in order to have it to function different things. On the contrary, this one has much less number of line of codes, which makes it more secure. You know, Flexibility. This is more flexible because it has more features. This one is less flexible. Performance-wise, it can be slower again because the number of line of codes in the kernel. Here, less line of codes, which makes it faster. And this makes it more portable than this one over here. So by looking at this figure and this table here, you can see that the best choice between both of them basically it's based on your specific needs of the application. For example, the mono one may be a good choice for simple embedded system that does not require a high level of security. Here we saw that thing here. While the microkernel may be a good choice for a complex system that needs to be highly secure and flexible. Okay, so let's talk about a very important topic called supervisory control and data acquisition system, SCADA. Now, SCADA are complex industrial control systems that are used to monitor and control geographical, different type of assets. They are primarily utilized in different type of industrial processes, like including manufacturing, power generation, water treatment, and oil and gas refining, and much, much more. Many of them may have embedded system as a component. SCADA system controlling critical infrastructure are usually separated from the internet by something they call air gap, complete separation. Now, an incident that happened back in March 2023, the attack targeted a water treatment plant in Florida and used a new type of malware called Triton. This one is very sophisticated malware that can take control of industrial control system, ICS. The attackers were able to gain access to the plant's network and inject malicious code into control system. What happened is that the plant went down and released untreated water into the environment. Now, what about cell phones, smartphones, and PDS? Conversation over those traditional landline phones are usually protected unless you tap the line or compromise the telephone exchange and among some other things. Used to require a lot of time, expensive equipment, and warrant. May have the same security expectation of the cell phones, smartphones, and others. Now, cell phone vulnerabilities include the following: attackers listening to your phone calls, using the phone as a microphone, or even cloning the phone to make long distances. Now, what makes things much worse is now we're using a smartphones, and the smartphones, they have their own operating system. Like security researchers and attackers have created many JavaScript viruses and some other type of viruses which can infect phones like Google Android and Apple iPhone OS. Now, Windows Mobile is no longer in use. Now, the line is basically blurring between embedded and general purpose OS. Those OS have vulnerabilities that can compromise your smartphone security. Now we are using a lot, a lot of us, we use wearable technologies, like smart watches. And this can increase the vulnerabilities of smartphones because interaction through Bluetooth. And you could simply search online for Bluetooth, vulnerability attacks. You will see a lot of examples. Also, we have a lot of Trojan application, that have become a big concern in the mobile application stores, and these are the examples. Now, if you want to learn more about the mobile phone vulnerabilities and securities, please check my YouTube channel and go to the playlist called Secure Mobile Devices and Technology, where I explain the mobile security in perspective, types of mobile security threats, mobile security mobile devices from physical and cyber threats, password management, securing shopping through mobiles, and some others. Let's talk about rootkits, right? Rootkits, basically, the purpose of it is what? To gain unauthorized access to a computer system and hide their existence, from detections and administrators. What they do, they tampering with operating system at different levels to conceal their activities. And and basically they install themselves as a kernel modules, drivers, libraries, and application, and you can find in different operating system. Now there are many rootkit detection tools and antiviruses. It can help detect and prevent installation, but it becomes really difficult if the operating system has already been compromised. you know, Rootkits can monitor the operating system for anti-rootkit tools and can neutralize it. Now, there are many, many different type of threats over here. The first one, the firmware level rootkit that basically, like a good example is the BIOS rootkits. They're rare, but can affect the BIOS firmware, making detection and removal extremely challenging. You know, However, they are very, very dangerous. Okay, because they are small in size and they'll be loaded in a low-level, non-volatile storage that even anti-rootkit tools cannot access, and can be persistent for a long time, even if you formatted the hardware. There's also another example, the kernel level rootkit, which can add or modify kernel modules to execute code with the highest privileges. Like, for example, like in Unix-based system, they can tamper with the system call tables to intercept and modify system calls. Now, uh, also you got driver manipulation, like especially like for Windows, like some of those rootkits replace or extend, those supposed to be legitimate drivers, allowing them to execute code at a privilege level. Now, also we have boot level rootkits, that the one that infect master boot record, MBR. They can modify the initial boot code, ensuring that the rootkit is loaded into the memory before the operating system, that's basically the typical booting process, by the way. And now, if you're using a dynamic BIOS called UEFI rootkit, you know, those are considered to be modern firmware. Now, these rootkits embed themselves into the what is called UEFI to persist across, OS installation and updates. Now, there is an interesting hardware. It's called the Trusted Platform Module, TPM. So what is TPM? If you look at the screen over here, this is a dedicated microprocessor designed to secure hardware by integrating cryptographic keys into the device. Uh, it has different functionalities, including secure boot, data encryption, and hardware-based random number generation. And for example, like you could take this one and plug it into the motherboard, and in many cases you could find it built into the motherboard itself. So the whole idea here is what? Is that it acts as a defense against low-level rootkit. It ensures that OS has not been sabotaged or corrupted, and it followed this ISO standard here. Now, the thing that you need to know that TPM can help in some cases to detect firmware rootkits by creating a cryptographic hash of the firmware. Now, any modification to this firmware, it will be detected by the TPM that has been modified. Now, the problem here is that many firmware rootkits are hard to detect, as the code for the firmware often isn't checked for possible correction. Basically, which means that there are some limitations out there, like especially for the post-boot attacks. The TPM's protection are strongest during the boot process and less effective against attacks that occur post-boot. Now, the problem there could be extremely sophisticated rootkits designed to evade detection by faking TPM responses or by compromising the TPM itself. Okay, although this is highly challenging and very rare, by the way, you know. And another thing here, we have insider hacking, that also makes it harder to detect with malicious code hidden in a flash memory of, of their company computers before they leave the company. Now, here is some example why this is really, really serious things. Now, there happened before the systems that are compromised even before purchases. And these systems that has been compromised with the rootkit, they function like normal. Like in 2015, a security firm called Trustwave found that a number of super microservers had been compromised with the firmware rootkits. They were installed at the factory before the servers were shipped out to customers. The rootkits were designed to give attackers remote access to the server. That's a big disaster. In 2019, it was discovered that a number of Android phones have been infected with malware before they were sold to customers. The malware was designed to steal the user's personal information like passwords, credit card numbers. So the only thing you could do in this case basically to flush or rewrite the BIOS with a non-clean copy. Wipe the hard drive completely and reload the operating system from clean installation media. However, the problem, this can be very expensive and time consuming. Now, what is the best practices for protecting embedded operating systems? First of all, you need to identify all embedded systems in the organization. You need to prioritize the systems or functions that depend on embedded systems. Obviously, follow the least privilege principles for access to embedded systems. Always use encryption for transporting data. Configure embedded systems securely by following the manufacturer's recommendation. Use cryptographic measures for booting embedded system, which we discussed it before, like TPM. Install patches and updates. Restrict network access to only the IP addresses that need to communicate with embedded system, and reduce attack surface by disabling or blocking unneeded services. A lot of these has been discussed previously. Upgrade or replace embedded system that cannot be fixed or pose unacceptable risk. Finally, by the end of this lesson, you should be able to explain what embedded operating systems are and where they are used, describe the IoT and other embedded operating system, identify vulnerabilities of embedded operating system, and best practices for protecting them. And finally, I want to thank you so much for watching this video lecture, and I hope you enjoy it, and I hope you find it useful. Thank you again. Now let's talk about next embedded system, embedded Linux. We know it's a free open source and can be found in industrial, medical, consumer items. And there are many embedded versions of Linux and other Unix or other Nix operating system that designed specifically for devices with limited memory or hardware capacity. Now, what is the advantage of the monolithic kernel? It's supposed wide variety of hardware. Also, it allows adding feature like using dynamic kernel modules. Now, what's this supposed to mean? The dynamic one is that it's a kernel extension that can be loaded, unloaded at runtime. This makes it possible to add or remove features to the kernel without having to reboot the system. They are used to add support for, for new hardware devices, file system, and drivers. Also, you could add new features to the kernel, like support for the new network protocols or encryption algorithms. Yeah. Now, we already discussed about the Wind River Linux previously, and now let's talk about the Linux DD-WRT. This is embedded Linux operating system. You could find it in different small office or home routers, like Netgear, TP-Link, D-Link, and ASUS. And for Linksys, for example, these models, they utilize this type of embedded operating system. And here you could see, you know, a picture of the firmware configuration for it here, right here. Okay. Now, what are some of the features? You know, uh, it has advanced routing. It helps you to configure the routers, to use more advanced routing protocols. It has support for a wide variety of VPN protocols like Open VPN, PPTL, and the QoS for, to prioritize traffic to improve the performance of a certain application or services. It also has some security features, like, you could configure the firewall, DHCP snooping, and by the way, DHCP snooping implement on the network switches to combat rogue DHCP servers and protect against DHCP-based attacks. And it's also highly customizable, allowing users to change the look and the feel of their routers, especially some ISP, they like to buy those and customize it, in their own format. Now, what are type of vulnerabilities of embedded operating system here? You know, the easiest way to profit from hacking, attack devices that store and dispense cash like ATM. ATM machines are, vulnerable to attacks, against their software, whether, locally or remotely. And physical attacks, also could occur, which can involve card skimmers or even stealing the machines. Okay, now a very simple search on YouTube, you will see a lot of examples of people basically using explosive attacks on ATM, like what happened to, here in Australia and also in Canada, Brazil, also, include physical attacks using heavy machinery. However, there are certain key physical security features of ATMs. It's hardened, safe. The reason behind this is that most ATM have something they call it UL291 certified safe, which is designed to withstand physical attacks for a set period of time. And it has certain materials that are resistant to drilling and cutting, by the way. Also, it has sensors and alarms. you know Also, some of them, they could have ink dye system, that will stain the cash, if you try to force yourself and, by breaking into ATM machine. And there's also another thing, those ATM machines are extremely heavy. Now, embedded operating system are network, yes, indeed. And here the network testers should address questions such as what PCI or USB devices are present, where they manufacture, is the supply chain trustworthy, which devices have embedded operating system stored in rewritable format, you know, because rewritable memory can be flashed, which embedded OS is currently loaded on each device. Can you make sure that embedded OS has not been corrupted, or modified, with some sort of malicious code? Now, quite frankly, to answer these questions with precision, this will involve combination of manual inspection, automated tools, and possibly even physical hardware examination. You know, However, to conduct a thorough, security assessment for a system with these type of, connection devices, and with embedded operating system, a security tester should consider the following key questions. Like, first one, you need to identify those devices. You could use specialized software to enumerate all connected devices. Uh, Concerning the supply chain trust, you need to investigate those manufacturers for compliance with the security standards. and chain integrity. Will be good idea to to hire third party audits, as a reference here. Uh, okay, memory type also. You want to know if these devices have embedded operating system stored in rewritable memory. Uh, use technical specs, runtime analysis, if necessary, physical inspection. Okay, there's another thing, the loaded operating system. You know, you gotta probably need to do system queries or cross-verify with vendor documentation to determine which embedded operating system is running on each device. And of course, OS integrity, ensure the embedded OS has not been tampered with, by using checksum, checksum verification, or file integrity. Now, embedded operating systems are difficult to patch. Well, when it comes to general purpose desktop like we use daily basis, you have to wait for vulnerability to be identified. Then you download it, you install it. You might end up restarting the system. So patching is simple. However, for embedded operating system, must continue must continue operating regardless of the threat, particularly in critical system here. You know, well, why? I mean, think about it. Some of those critical systems, they have safety concerns, like, system that controlling critical infrastructure or medical equipment, must function without interruption to ensure human safety. Also could have economical impact. Imagine the failure or the downtime in the system like this, like in a financial trading platform, you know can result in significant economic loss. However, system like this usually are often designed with redundancy and failover, to maintain functionality here. Now, patching may be a problem. System administrator may have no clue how to patch a web server running on a tiny chip. Yes. Well, maybe those system administrators lack the specific knowledge required to patch unconventional system like web servers running on embedded chips. You know, uh, Patching usually requires downtime, which is not an option for critical system. Okay, and also in some cases, patches may break existing functionalities or be incompatible with other component there. Now, we're already familiar with the buffer of overflow attack. Now, okay, there are a few updates are released to correct vulnerabilities, like manufacturer may prioritize the new features and system upgrades over security patches. The support lifecycle for embedded system is often shorter than their actual operational life, leading to system without updates. Manufacturers typically prefer system upgrades, which is especially if you buy it from unknown manufacturers, uh, because from business perspective, those manufacturers may prefer releasing entirely new systems so they can make more money as opposed to continuously supporting older system with patches. You know, uh, the problem here, updating or upgrading to a new system often involves significant changes, which could be impractical for an environment, where continuous operation is extremely important. Now, embedded operating system are in networking devices. Attacks that compromise a router can give attackers a complete access to every host on the network. Attackers follow usual methods of footprinting, scanning, and enumerating, even for embedded or IoT devices, in order for them to compromise the entire network here. Now, authentication bypass vulnerability, this is very common when it comes to routers and another network devices, especially with the built-in web management interfaces. I mean, you could search online for examples of this. You will see, this will include, not only routers, even printers that have web or built-in web management interface. Like especially like if you try to create or design a crafted URL to bypass the normal authentication mechanism. You know, the crafted URL bypass, the attacker can manipulate the URL parameters or the structure itself to skip the standard authentication right here. You know, so if they can bypass authentication, they will have access through compromise, through compromising the router to, the whole network here. Now, there are common devices on the organization network, like the multi-function devices, it has a printer, scanner, copier, and fax machines. So you could see that they do more than one function. They are rarely scanned for vulnerabilities or configured for security. They do have embedded operating system, and with sensitive information. Now, the problem here is that these devices often run on embedded operating system that store sensitive data, making them attractive targets for both local and remote attackers. Now, their embedded nature often means they are not regularly scanned for vulnerabilities or appropriately configured for security. As a result, they are susceptible to a range of exploits. It could range from data theft to modification to insertion of malware or malicious links. And also possibly to a social engineering attacks where intruders may pose as a support technician. A good example of these printers, read about it, like the CVE back in 2020. There was like this vulnerability discovered in some HP multifunction devices, allowed the attacker to remotely execute arbitrary code. HP eventually released a firmware update to mitigate this risk. And there's also Samsung. It happened several years ago as well. You know, and in some cases, printers, in fact, here, printers should be reconfigured before connecting them to the network. That's the recommendation. Most printers have only TCP/IP enabled, but unfortunately, default administrator username and password are still configured. Now, this one here, if you look at it, this is example of poo die pi printer hack output. This happened back in 2018. A hacker claimed to have exploited more than 50,000 vulnerable printers worldwide. Again, claimed. And this hack allowed the hacker to print out messages arguing people to subscribe to the YouTube channel of this Poo Die Pie. What happened is that the hacker exploited open printer ports. Uh, to be exact, it's port 9100 that were exposed to the internet, and many printers are shipped with this port open, by default. And the organizations, unfortunately, often overlook closing or securing these ports during the setup process here.